Okay, so in this question's going to ask us about all the asymptotes that can exist in this function. So if we're thinking all the asymptotes, we're thinking, oh, I don't like that. Let me erase that. There we go. So if we're thinking all asymptotes, so let's just go ahead and list all the possible asymptotes we can have. We can have vertical asymptotes. We can have horizontal asymptotes, and then we can have oblique asymptotes. So vertical, horizontal, and oblique. So with vertical asymptotes, the rule that we can use is to set the denominator equal to 0. With horizontal asymptotes, we have to look at the leading term of the numerator compared to the leading term of the denominator. We'll do that in more depth in a second. And then oblique asymptotes is pretty much the same thing as the horizontal. So we're going to look at a specific case that will determine our oblique asymptotes. So let's go ahead first and find the vertical asymptotes. They tend to be something that's not so bad. So vertical asymptotes are the graphical way that we are able to show where the function does not exist, where there is a 0 in the denominator, where the function is undefined. So vertical asymptotes are the graphical interpretation of determining where the function does not exist. The function does not exist, so if we want to find vertical asymptotes, we have to set our denominator equal to 0. We can solve this guy rapidly by factoring, so we're going to get x, let's think, x plus 4 times x minus 1 equal to 0. That's supposed to be an equal sign. Now we can set each one of these factors equal to 0. And we subtract 4 on both sides, so we get x equals to 4. We're going to add 1 on both sides, and we get x equals to 1. And notice in these circumstances we have two equations of vertical lines. And notice whenever we have x equaling to a constant, that we know this is the form of a vertical line. And these will be the equations of your vertical asymptote. So if we were to look at a graph right now, if we were to graph this, or just these vertical asymptotes, we know at 1, we would have a vertical asymptote. So if this was a 1, we would have a vertical asymptote, which is a dotted line that the graph cannot pass. And then over, it just keeps erasing things on me. And then over here at 4, we would have another, I think I could use, let me look and see if I have any other options for pens. I don't think I do, but we can just assume this will be another vertical line. So these are dotted values. They indicate the graph cannot pass, so it's just going to be dotted. For some reason, it doesn't like doing that. These dots, so it just keeps deleting the dots on me. So we have those. So that is going to be where our vertical asymptotes exist. We set our denominator equal to 0. So now, in order for us to find our horizontal asymptotes, we're going to have to look at our degree of our numerator in respect to the degree of our denominator. So these are going to be specific to rational functions. So we're going to define f of x in terms of a leading coefficient on top, a sub n, x to the n power, plus all the way down to your constant a naught. So this will be in the numerator. All over b sub m, just a different subscript, x to the m power, all the way down to our subscript b naught. So what we look at specifically for horizontal asymptotes is that we look at the leading terms. So this is a b sub m. We're going to look at our leading terms. So we're going to look now at our relationship of our degrees. So let's just look at our degrees. If n is greater than m, if n equals to m, and our third circumstance is if n is less than m. So if your numerator degree, n, is greater than your denominator degree, m, then I call this top heavy. top heavy, n is greater than m, n is greater than m. If this is equal, I just call the degrees equal. And if n is less than m, that means the denominator exponent is larger, the degree in the denominator is larger. So now we call this bottom heavy. Okay, so if your degree of the numerator is larger, we call this top heavy, and there will be no horizontal asymptote that exists. We actually get an oblique asymptote. So if you are top heavy, then no horizontal asymptote will exist. You will have an oblique asymptote. If they are equal, if n equals to m, if your degrees are equal, you will have a horizontal asymptote. Horizontal asymptote, think an equation of a horizontal line. That will fall in the form of y equals to the ratio. It'll be the ratio of their leading coefficients. So this will actually fall in the form of y equals a sub n divided by b sub n. And then lastly, if they're bottom heavy, I know the way that I use this analogy is I talk about the way I am over the holidays. I love my desserts. I love pecan pie. And I know sometimes after the holidays when I'm not worrying about my diet and I'm enjoying all these lovely desserts, I sometimes can't fit into my jeans. So if I can't fit in my jeans, I have to diet. Therefore, I know I have to eat 0 desserts. I know that if I'm bottom heavy, I have to eat zero desserts. So my horizontal asymptote will be the line y equals to 0, which is also known as the x-axis. So that's the analogy, it's sort of the metaphor that I use in order to determine these relationships. So if you're top heavy, a lot of times I say if I'm top heavy, maybe sometimes I have to lean to the side. I lean to the side, so maybe if this is me, I'll draw myself. And, I'm not that skinny. But if I'm top heavy, I'm still going to have to maybe lean to the side a little bit. Really, really, really flexible I am. But notice here, if I'm leaning to the side, I have an oblique or a slant, and this is also known as a slant asymptote. So if you're top heavy, sometimes you have to lean over to balance yourself, and you're also going to have an oblique or slant asymptote. So these two are synonymous. So if we look at this example specifically, we know that we have the function 2x minus 3 over x squared plus 3x minus 4. So if we look here, the degree of our numerator is 1, and the degree of our denominator is 2. So in this circumstance, we have our n value which is 1, and our m value which is 2. So our f of x has a degree of x to the, well, I don't know why it keeps deleting that. Oh, that's not good. What happened to everything? Okay, I've somehow lost everything. Oh, there it comes back. So I know in this circumstance, I'm going to have my f of x in my numerator, which will be an x to the first, all over my denominator, which will be some value of x squared. I don't care about that. I just know that I'm bottom heavy. We're bottom heavy because we realize the degree here is a value of 2 and the degree on top is 1. Therefore, since I'm bottom heavy, I know that I have a horizontal asymptote at the line y equals to 0. So since I have a horizontal asymptote, I know I don't have an oblique asymptote. Therefore, the only asymptotes I have are the line y equals to 0, x equals to 4, and x equals to 1.